Number 30, find the sample proportion. Well, we didn't talk about that, did we? Okay. Well, the sample proportion and the margin of error. Find the sample proportion and the margin of error to the nearest percentage for an event that occurs 67 times in a sample size of 400. Okay, so a sample proportion would be, all right, is the relative size of this when you look at the entire data. Okay, so that it's kind of embedded in like to calculate the sample proportion is basically figuring out if a certain event happens 67 times out of 400, what percentage is that? 67 divided by 400, okay, it happens 0.1675 times. Isn't that 1/8? No, 1/6. Okay, close to 1/6. So that means 1 out of every 6 things that happen out of 400 is out of 6 events, one of them is going to be this thing that occurs 67 times, okay, roughly. Okay, so that's sample proportion. Now, I'm not going to ask you that question. What I am going to ask you about is the margin of error. Now, the margin of error has 2 formulas, if you remember. This is categorical data, and then this is when you actually have the quantitative data, okay? And the quantitative data means that you actually know what the sample size and the standard deviation is. In this one, you only know the sample size. And in this case, we only know the sample size. The 67 times was just used for the proportion, okay? So I just use this straight up formula right here, which is 1 divided by, and I put this in parentheses, 1 divided by the square root of 400, which I actually do know is 20. So 0.05. Now what does 0.05 mean? It means that I'm going to have 400 is a big sample size, especially if you were thinking about surveying the school. If you got 400 students, that's cool. It looks like you got some elementary school kids as well. That means that you're approaching like the size of the population, at least in our school. But 400, that's a lot. That's a big sample. So you're looking at an error of roughly 5%. Okay, so that means whatever the mean is, you could go 5% this way or 5% that way. Okay. All right, so that means if we ask, a particular question, say 80% of students is this, we could be off by 5%. Okay, that's our margin of error. Number 31, suppose a population has a standard deviation of 32.5 and a sample size is this. Find the margin of error. Okay, now we have a standard deviation. So if we have a standard deviation, we're not going to deal with percentages anymore. We're going to deal with this population. So that formula is here. So we take 2 standard deviations, okay? Remember, 2 standard deviations in the front and in the back is 95% of your data. Here we've got 100% of our data. Okay, so 32.5 times 2 is 65. Now we're going to take that 65 and divide by square root of 350. Oops, don't need that. Okay, so this means that my margin of error is 3.5. Okay, 3.5. 3.5, we don't know what that means. Okay, we have no idea. As a population has a standard deviation of this, we don't know what 32.5 represents at all. We just know that the margin of error is 3.5 this way and 3.5 that way. 32, what happens when the margin of error, what happens to the margin, oh my, I'm so tired. Oh my God. What happens to the margin of error? It's not even 10 o'clock, I'm so tired. What happens to the margin of error when the sample size increases? Okay, well, let's just watch how the numbers work, right? And think about how high our margin of error was when we just had 50 people, right? We had 1, divided by the square root of 50, okay? And when you guys got 50 students surveyed, all right, your margin of error was 14%. You could be off by 14%. So that's kind of big. Well, you don't have that big of a sample size. But if I were to copy this, okay, and if I were to go 250, all right, notice that we actually dropped at least in half, okay? And if we get surveyed everybody in the district, including teachers, what is that? What are we at? Maybe 400? No, like I think it's like 380 with everybody. We'd have a 5%, okay? So a 5% margin of error. So again, when your sample size increases, your margin of error obviously decreases because you've got a bigger group of people. You're approaching the population. Okay, now 33 we're going to skip altogether because we didn't discuss that and there's just no need for it. All right, we've pretty much covered Common Core standards for normal distributions and the margin of error. That's it.